Hi, this is Math 6, Unit 7, Lesson 10, Interpreting Inequalities. So our first activity says true or false, fractions and decimals. Just some little thinking here to decide if each equation is true or false. They want you to take a look at this and decide if you think it's true or false, and then explain your reasoning. So when you look at the first one here, we can see we have 3 times the sum of 12 plus 5. What we can see happening here is it looks like they've done some distributing, right? 3 times 12, and we can see 3 times 12 there. And we can see a 3 times 5 right here. But the difference, though, is that this is 3 times 12 plus 3 times 5, whereas this one is 3 times 12 times 3 times 5. So because of that difference there, we would most likely say this is going to be a false statement there. And it's just a small little mistake that they made there. So something to be aware of if you make your own computational errors, just check for those things. Make sure that you're doing it right. When we look at these two, I think about the equal sign, right, is kind of saying that this is balanced, right? These are balanced across, and so I have the same thing on both sides. That's what an equal sign is telling us. And I can see a 3/4 and a 3/4 on both sides. So if I was to pretend those don't exist because they essentially cancel each other out, just like I could put an A there and an A there and they just eliminate each other, right? They balance out the same. I then compare the third and the 2/6. And when I look at a third and I look at 2/6, I know they're not the same digits, but what I might notice though is this. If I'm saying they're equal to each other, if I was to multiply this by 2 over 2, what do I get? 1 times 2 is 2, and 3 times 2 is 6, and I'm left with 2, 6 equals 2, 6. Now 2 over 2, of course, is the same as 1, so I'm not changing anything. I'm just, instead of reducing the fraction, I'm making it a little bit bigger by finding a similar fraction here with a common denominator, and now we see that those are equal. So this would be a true statement. When I look at the next one, what I notice again, these are all things being equal. First thing I saw is I noticed that the 2 and the times 12, I see 2 times 12, which is 24. And I pointed that out because I also then quickly saw that 6 times 4 is also 24, meaning that those parts are all the same, right? So I can kind of eliminate those because those parts are going to be equal to each other. 24, 24, cross them out. So I'm really comparing 1.5 and 0.75, which are very different numbers. So this would be a false statement there. Okay, let's move on to the actual lesson for the day, interpreting inequalities. It says Noah scored N points in a basketball game. Good job, Noah. What does 15 less than N mean in the context of the basketball game? Well, the N were the number of points. So the number of points that he scored is going to be, in this case here, greater than 15. So we could say that Noah scored more than 15 points in the game. Because this is Noah's score, right? Noah scored N points. So Noah's score is greater than 15. So that's one thing we could say that means right there. The second thing we take a look at is we go, okay, what does N less than 25 mean? Well, in this case here, again, Noah's points. This tells us that Noah scored less than 25 points. So we could say Noah scored less than 25 points in his game. And that's what we would say about those two things. So we know he scored more than 15, but less than 25. Now it wants us to draw two number lines to represent solutions to two inequalities. Okay, so the first one was that Noah scored more than 15. We could draw a number line like this. We could put the number 15 right here if we chose to do that. We could put 0 down there as a reference there. We know that he scored more than 15, so it's not that he scored 15, it was more than, so we do an open circle, and we draw an arrow going this way. They scored more than 15. We also know that Noah scored less than 25. So in this case here, we draw the arrow this way. We could maybe put 25 over here, and 0 over here. And we could say, well, it's less than 25, so we didn't get to 25, and we're going to go down this way all the way to 0. I could either point the dot here at 0, or I could just, it's better to put 0 because he scored less than that. You can't score negative, so we'll stop at 0. That makes the most sense. Now looking at this, it says, now name a possible value for n that is a solution to both inequalities. So we're looking for a number that would be more than 15 but less than 25 and fall in that region right there. So we could say something as simple as 20 is a possibility, right? Because 20 would be more than 15 and it would also be less than 25 and would be a solution for both inequalities. Name a possible solution for n that is a solution to 15 is less than n, but not for the other one. So a number that would work over here, but not over here. Well, we could pick something like, we could say, if this wasn't going on, we could say 30, right? 30 works for this one. It would go on to 30 and definitely capture 30, but over here, 30 would not be in that orange little line, so 30 would not work. So that's an idea from another one. Can -8 be a solution to n in this context? Now context is very important. Context means in the case of this story, talking about a basketball game, can -8 actually work and make sense in a basketball game? We'd probably say, no, it's not going to make sense. And why? Well, you can't score -8 points. That's just not possible in basketball. You can miss some shots, that's for sure, but you can't make negative shots. All right, let's look at the next page. In activity 3, we see, again, some unbalanced hangers. Here's a diagram of an unbalanced hanger. Jada says the weight of one circle is greater than the weight of one pentagon. So this circle is greater than the weight of the pentagon. And we can see that because it's heavier, it pulls down, right? So write an inequality to represent her statement. Let P be the weight of one pentagon, P, and C be the weight of one circle. So what are we saying? That this pentagon and this circle, we're saying the circle has a greater weight than the pentagon. So P is less than C. Now if a circle weighs 12 ounces, use this information to write another inequality to represent the relationship. Alright, so we already said that the pentagon is less than the circle, and now we're saying the circle weighs 12, so we can also say the pentagon is less than 12 ounces. So what does this mean in terms of describing it, and you can describe this with words, is that the pentagon weighs less than 12 ounces. That's what we know. Let's look at number 2. Here's another diagram of an unbalanced hanger. Write an inequality to represent the relationship of the weights. Let P be the weight of one pentagon, P, and S be the weight of one square, S. In this case here, we see the pentagon is definitely heavier than the square. So S is less than P, or we can also say the other way, P is greater than S. Now one pentagon weighs 8 ounces. So again, looking at what we started with, S is less than P. If the pentagon weighs 8 ounces, we're going to plug that in for P right there, and we're going to say that the square is less than 8 ounces. So we're describing what that's asking us, what this is saying that the value of the square, the weight of the square, is less than 8 ounces. Graph the solutions to this inequality on the number line. Okay, so for that one there, on a number line, we can graph it like so. We can have the number 8 right there, since we're dealing with 8. And we can go to 0 because it definitely is going to have some sort of weight. It can't be less than 0. It definitely weighs something because it's an object. So in this case here, because the square is going to be less than 8, it's not equal to, it's going to be less than 8, we would draw an open circle and have our line going here and stopping at 0. Because the value or the weight of that square could be anything between 0 and almost right up to 8. Alright? So based on your work so far, can you tell the relationship between the weight of a square and the weight of a circle? If so, what would you say? Well, what we know so far is we know that a square is less than a pentagon, and we also know that the pentagon is less than the circle, right? That was the first one and the second one. So in terms of the square and the circle, we can see that the circle is going to be less than, sorry, the square, keeps thinking circle with the S, is less than the circle. because that's going to make sense for all that to work together. So we would say that the square is less than the circle, right? Square is less than the circle. Here's another diagram of unbalanced hanger. Andre writes the following: circle plus pentagon is less than square. Do you agree with this inequality? So he writes this down: circle plus pentagon is less than square. Do you agree? Well, let's see what it says. Here we have a circle plus pentagon. It seems to be greater than the square, doesn't it? It's heavier, it's coming down more, as opposed to less than. So we would say proper inequality should be the circle plus the pentagon is actually greater than the square. That would be proper. So he has his sign backwards. It should go the other way. Jada looks at another diagram of an unbalanced hanger and writes: the square plus the circle is greater than 2 triangles, where T represents the weight of 1 triangle. That's a triangle, there's T. Draw a sketch. All right, so we have our triangle, our diagram like this. We'll draw our unbalanced hanger. Just go ahead and make it unbalanced so you just know what you're dealing with. And we know the one that's bigger or weighs more is on the low side is the S plus C. So we're going to do our square plus our circle, because that's the heavier side, and that's going to be more than 2 triangles. Something like that, right? Because this is going to be greater than that one there. Again, you could have drawn it this way too, if you want to kind of stick with the picture. That probably would have been better for me to do that for you, I'm sorry. And you could have gone something like this, right? So that would show that S plus C is greater than 2T. Okay, and that might be a better way of drawing that. I just didn't think that through about it. All right, so there you go. All right, so let's take a look then at our summary. When we find solutions to inequality, we should think about its context carefully. So context is important here. A number may be a solution to inequality outside of a context, but may not make sense, okay, when it's considered in context. So it may be a solution, but may not make sense. So you want to make sure that it does make sense. So suppose a basketball player scored more than 11 points in a game. We represent the number of points she scored S with the inequality S is greater than 11. By looking only at S greater than 11, we can say the numbers such as 12, 14.5, 130.25 are all solutions. They make it true, right? And those are all true. That's true, that's true, that's true. But when we're talking about points in the game, right, we're only talking about whole numbers. So in that case there, the context of the inequality may limit the solutions. So yeah, it works, but because we're talking about points, you know, you really can't use 14.5. You could have 14 points, you could have 130 points, but you can't use that. Again, they're true, but the context says, think again, okay? So other times though, it might be okay to include numbers. Okay, so this is when talking about the number of minutes that it rained yesterday. You can have lower boundaries, higher boundaries. There's different things you can do, and you can use inequalities compared to unknown numbers. We're going to pause there, let you work on your homework, and then we'll check it together in just a moment. All right, homework time. There is a closed carton of eggs in May's refrigerator. The carton contains E eggs, and it can hold 12 eggs. Okay, so it has that many, E, and it can hold 12. What does the inequality E is less than 12 mean? So that means, in this case here, that the number of eggs we have is going to be less than 12. So number of eggs is less than 12. Okay? What does inequality E eggs greater than 0 mean? Well, for us it means the number of eggs is more than 0. What are some possibilities of E that will make both E less than 12 and E greater than 0 true? Right? So in this case here, you're talking about numbers between 0 and 12 that would make that true. Now, think about context. Can I have half of an egg? Well, in the carton, probably not. So we'd be able to say that anything like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, those are all possibilities, aren't they? So any number between 0 and 12 is going to be a possibility. We could write any one of those there as options. Number 2. Here's a diagram of an unbalanced hanger. Write an inequality to represent the relationship of the weights. Use S for the square and C for the circle. So in this case here we have a circle, right? We have a square, and the circle is greater than the square. So we can write over here, C is greater than S. Now one red circle weighs 12 grams. Okay, so how will we do that there? The circle is C, so we're going to say 12 is greater than S. Could 0 be a value of S? Could 0 be a value of S? So could this square weigh 0 grams? Think about it, context. It's there, it exists. Does it weigh nothing? If it exists and it's there, does it weigh nothing? We would say no. It couldn't be 0 because it does exist. It needs some sort of weight because it's there, okay? Even if it's little itsy bitsy, it still weighs something. All right, number 3. Tyler has more than $10. Okay, so let's use Tyler here. Okay, we have T for Tyler. So Tyler has more than $10. So whatever Tyler has is more than $10. Elena has more money than Tyler. So Elena has more than Tyler. Great. May has more than Elena. So May's over here. Let T be for Tyler, E for Elena, and M be for May. And select all the statements that are true. Now yours might be more updated. I have one of the original versions here. On this one here, I have no idea why there's a J right there. So I'm not sure what yours says, but I'm just going to write a big question mark right here because I don't know what that's supposed to be. Okay, maybe it was a different letter and there's a typo, and in your version it's corrected. Mine, I have a J, so don't worry about it. Okay, so is M more than 10? Yes, it is. So that's going to be true. Is E more than 10? Yes, it is. That's true. Is T more than 10? Yes, it is. That's true. Is E more than M? No, E is less than M. That's false. And then is T less than E? Yes, that's true. So for what I show right here, we would have 4 trues, 1 false, and 1 that I have no idea what they're talking about. Okay, number 4. Jada is taller than Diego. So Jada is taller than, greater than Diego. Diego is 54 inches tall. Write an inequality that compares Jada's height in inches, J, to Diego's height. So Jada is more than 54 inches. That's all you have to do. Okay, now let's continue that with the next one. Okay, same people. It says that Jada is shorter than Elena, and Elena is 5 feet tall. Write an inequality that compares Jada's height in inches to Elena's height. Now here's a trick with this one here. We could say that Jada is less than 5 feet, but that's 5 feet. We're not dealing with feet, we're dealing with inches. So how many feet are in an inch? There are 12. So multiply 12 times 5. 12 times 5 is 60. So we would say Jada is less than 60 inches. So make sure you read that full problem to convert that over to inches so you know what's going on. Number 5, which is greater, -9/20 or -0.5, and explain how you know. If you get stuck, consider plotting the numbers on a number line. Okay, so let's look at a number line real quick, just because we can. All right, these are both negative, so here's 0, and here is -1. Now -5, or -0.5 is about there. Where would -9/20 be? Well, you have to imagine this is going to be, in our case here, right here's 1 point here. This is, you have to take this space and imagine 20 little lines in between, which means 10 per. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So -9/20, it's just going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. That's where -9/20 is located in terms of its distance between 0 and -1. So which one is actually greater? Now in this case here we're doing negative numbers. Greater means what? Closest to 0. That's the larger number. The one on the right is greater. So the one that's greater is going to be negative 9 over 20. Number 6, our last one. Select all expressions that are equivalent to 1/2 cubed. Well, that's 1/2 times 1/2 times 1/2. If I solve that out real quick, I get 1 over 2 times 2 is 4, times 2 is 8. Let's see what I have over here. Well, this one sure does look like what I have right there. That's great. This is 1 over 2 times 2 times 2, which is still going to be what? 1 over 8. Looks good. This is 1/3 times 1/3, which is 1/9. That is not going to work for us. This one's simply 1/6, just not going to work for us there. And that one is already 1/8, which matches that one, so we're good there. A, B, and E look like great answers. All right, that's it for today. Have a great day, and we will see you next time.